Thanks, team. And just to match you, I'm drinking out of my favorite Terraform mug today, just straight water today. So, but let's talk about Terraform testing and what we can do to keep from breaking things for our customers. As they mentioned, I'm Jeremy. I'm HashiCorp ambassador, and I spoke at HashiConf this year. And as part of that, there was an impromptu hallway talk about Terraform testing amongst myself and some other fellow ambassadors. And so a lot of the key points in this talk today come from areas of concern, areas of challenge, areas of interest that folks had around getting started with Terraform testing. So we'll look at some intros. We'll jump into Terraform state just so everybody understands how that works with testing. We'll look at scale with pipelines, and then we'll do some mocking and we'll wrap up and call it a day. So let's get started because we have a lot to cover. If you've never used a Terraform test framework, it's very simple, HCL language based. If you're writing Terraform today, you're already there. You should be able to write Terraform tests by this afternoon and be up and running. You'll be familiar with the language structure and how it works. It's integration testing, right? Test your modules locally before you push them up to a repository and commit them and create new versions, and then test them as part of CI/CD as integration testing, so testing them nightly against our different cloud providers. And it's part of the 1.6.0 release or later. I hope you are using something later, but you at least need to be on 1.6 to use it. 1.7 brought in some major enhancements as well. So a minimum, I would say 1.7, but it was introduced in 1.6. Why Terraform testing? Module validation. Our variables. Are our variables being evaluated as we would expect them to be? Did the region they pass align with the regions we allow? Did the regex expression on our name for our resource match what was passed to us? Provider verifications. Our wonderful folks at Azure and AWS and Google release provider updates weekly. And so those releases occasionally will break things within our modules. And unbeknownst to us, we need to capture that before our customers do. So that's a good reason there. And lastly is capability verification. Dynamic blocks, things of that nature, different capabilities you build within your modules, all those things need to be tested frequently to ensure that we haven't broke anything. Now, what does this look like within your module? I'm using a storage account module today, but there will be a test folder. Very straightforward. Within that can be one to many, what we call setup or pre or post folders that can do work for you. But then lastly, the actual meat and potatoes, TF test HCL. Now, if you prefer JSON, feel free to write those in JSON. Now, the setup TF or setup file for just a minute, that might do something like create a resource group for me, for my storage account to land in. It might create a VPC for my EC2 to land on as part of my testing. So that's set up ahead of time. There could be post testing, right? I deploy that web app and I want to make sure I get a 200 back from an index HTML or something, just to ensure that I have in fact connected all the dots with networking in the cloud, which can be a beast of its own. All right, so what does the file look like? Our test, tf-test.hcl has many run blocks or can have many run blocks with as many providers as you need. In some cases, you might need multiple providers to handle different scenarios, and you can pass those in. And next is our command, defaults to apply, but otherwise you can list it as plan or apply. I'm always very explicit in mine to ensure that the next person in line knows what I'm doing. Variables. Variables can be inside the run block to pass into your module. If you're not using defaults on all of your variables, then you'll need to pass variables. They can also be global variables, so they'll be outside the run block, which will apply to all of your run blocks if you have multiples within your test tf-test HCL file. And we'll see that in just a little bit. And lastly, the best part, assert, do validation against what you think should be deployed and what actually got deployed. So these assert blocks will allow us to validate, hey, I created a storage account. Did I actually get a primary access key that could be leveraged by a customer to access the storage account? All right. In the grand scheme of things, if I write the TF test file well, and I have several tests to cover all the many different conditions, I might end up with several different testing files, as well as plans and a combination of applies. Plans should test everything, every possible validation of variables and scenarios. Where applies will typically take longer, should test your critical paths that your customers tend to take to ensure those are good. Because applies do take a while, whether you cover every scenario or most of your high priority scenarios is kind of up to you. But with plans, they're short, should cover everything. Let's talk, folks. Let's look at some code, right? That's how we like it. So let's look at code. In our storage account, we have a test inside here. We have a setup. So let's just think about what we need to set up a storage account. That would be a resource group. And so that's all that's in here. So that when I create my resource group, I am in fact getting a unique resource group. If you're building resources as part of your test, you want them to be unique so that if you have multiple tests in parallel, you get unique resources. What you'll find is if you don't use unique resources, you'll get overlap. And so what we want to see is the use of random resources to ensure we get unique resources created in the cloud. All right, so let's look at our actual plan. And within our plan, there we go. Yes, okay, says I'm back. So yep, here's our test file. We set up an RG using a run module, and we called the setup directory. And then we actually set up the actual storage account. As part of this plan, I want to validate should be at this time. And if it's not, it will return a message saying the storage account name is incorrect. And that would be an assertion. Now I want to show you something as part of this test, that if I attempt to run a test and look for a particular resource that is not created until apply time, our tests will fail. In this case, primary access keys are unique identifiers given to a storage account upon creation. So as part of a plan test, storage access keys are not generated. And so if I attempt to test for that, it will fail. And so we want to consider what variables and parameters we're testing for, depending on whether we're doing a plan or an apply. So this would be a test that I want to do in an apply step, but we'll go ahead and let this fail out. We'll take a look. We'll take a look at my storage account module, but I'm expecting a failure. So I know my name's going to fail because I see the 24 characters or 28 characters that is allowed by Azure. It's not very good. So, okay. I seem to be back. Okay. Sorry about that. Seems to be some network lag or something. So yeah, let's talk about the state, about what's going on behind the scenes to a Terraform test. According to Hashi, there is a state file that is created for each test file that will hold the state for all of the run blocks within that test file. Okay, I'm gonna stop cam. Okay, I'm going to stop my game so we can get good audio out of this. But according to Hashi, we get one state file for each test file, and that'll contain the state for all run blocks. Now, if you have a run block within your test that has a module block, it'll get its own state. So in the scenario before, we had one file with multiple runs, and within that, we get two states because our setup RG actually called a separate module. And in doing so, it gets its own state. But the subsequent next test for creating a standard storage account gets an applies state in the back end. And the second test we had to change the tag will update the same storage account in place. It won't tear down the storage account and create another one. It'll update the existing storage account in place because it's inside the same test file. So think about that as you consider how you build your test cases. If you're building a VM, um, if you're building a VM for 2016 OS, but then you want to also test 2019, you may not want them in the same test file because it'll tear down the 2016 and rebuild a 2019. And in doing so, you'll extend your test times pretty dramatically. Having those in separate test files will allow you to run them in parallel and ensure that you're not waiting for resources to destroy and recreate all within the same test. So hopefully we covered some of that. And at this point, you are familiar with testing framework association. And we want to look at a little bit more advanced topics around how we can test things at scale. So we're all familiar with the module lifecycle. You've created your first module, and now your customers are happy. You've provided a storage account module. They can deploy storage accounts. They're happy. All things are wonderful. They come back and would like to add some enhancements. You create a v1.1, release that, and they are essentially even more happy that you've provided more functionality. And the next day, one of our cloud providers provides a provider update, which requires a breaking change, and you release v2.0.0. This is a very common life cycle we're all expecting and have seen this before. But how do we test all versions? Because we have customers who onboarded with 1.0 and are very happy. And we have customers who upgraded to v1.1. And of course, we have our bleeding edge engineers who always have the latest and greatest version in their code, and we love them. But they are on v2.0. But we cannot abandon our customers who are on the older modules. So how do we handle testing multiple module versions within HCP and our pipeline? HCP Terraform Cloud handles this using a branch-based configuration. When you import your module into the registry, you need to use branch-based. You have to click a button, a checkbox to enable testing, and it can test the latest version of that module. So whatever version you have set in HCP Terraform registry, it will test that latest version. It'll also test runs when new commits. So when you make a change to your module and commit that in, and it sees it in the repository, it'll run those tests for you, which is very nice. You can trigger them dynamically or on the fly from the CLI as part of the Terraform test command using the -cloud-run and then giving a path to your repository in the registry, HCP registry. Or you can test it via CI/CD pipelines. And this is going to still use your HCP registry modules, but it's going to use a version tag, the difference being the version tag versus the branch base. And this will leverage this Terraform CLI test commands as well, slightly different, but in a similar fashion. But you can test one-to-many versions. You can test, if you're using tags, you can tag each release as 1.0, 2.0, and you can test all the different versions of that within your repository to ensure that you are not breaking past versions. Of course, as part of pipelines, you can set this to run on a cron schedule and allow that to notify your engineering teams as part of nightly runs. So let's take a peek at that. What I have done, and we'll get over to the proper window here, is set up my Terraform HCP pipeline and we'll give it just a minute. There it is. And we'll see that I have got it testing my storage module, my Key Vault module, and my virtual machines module. Inside of each, we can see that I do an install of Terraform. I set up my login credentials in the back. I initialize my root module and my test module, and then I do my test. And as part of that, I can see results for my different test passing. I have some variables I need to clean up, but that's okay. We still see successful tests coming by. And at the end, we have passed all of our tests. Now, when it comes to testing many OSs, I want to look at that. I'm going to take a little zoom out, but I can see that I'm testing my different versions of my OS. Now, they're all sequentially. 16 must complete before 19 can start, and the same for 22. And this is for plans and applies. So we end up going sequentially, and we find that this can take a long time, up to 12 minutes for all my testing to go through. And what this is doing in the background is taking a matrix of the different modules I would like to test, and then beginning to test them and running Terraform test cloud run at each of those. So I'm running them all in parallel at the same time, and the total test time for my run is the total time of the longest repo. So that was 12 minutes on my virtual machines. My total runtime was 12 minutes. I've now covered all of my modules to verify them in about 12 minutes. Now we can expand this to as many modules as we want. And it's really based on how many run agents you have behind, say in GitHub runners or Azure DevOps build agents. Now, the other way that we can do this, and my preference here, is to actually just let the Terraform Test Framework handle call the test within. Just a second here, spinning. Again, same test, same modules, but I'm at 6 minutes. I've cut my time in half. And the way I've done that is I've called each of the test files individually. So each test file gets its own run. And we begin to see that each of the runs, this is a different run, I apologize. Shorter run. But essentially what we did was we took each test file and ran them sequentially in parallel at the same time to ensure that we don't have any delays for waiting for resources to tear down or build back up. And so we're able to do those together. Hopefully this should have been, oh yeah, actually I was looking at it before. I just misread it. So this is my 2016 test, and this is my 2019 test, and this is my 2022 test. So I ran them all at the same time, and that's how we're cutting down our test times. This allows us to run all of our module testing in a given time frame that doesn't take hours upon hours upon hours to test all the different scenarios. And in this one, again, I just leveraged the matrix capability to be able to call out the different scenarios that I want to test. I have different test files for testing the different OS versions, and then it goes through, builds my credentials, it builds my login, and finally it builds out the testing. In this case, I'm not calling the Terraform HCP cloud, I'm actually calling the file within the repository and running the test in a way locally to the build agent. I'm calling Terraform test right there locally instead of calling out to the HCP cloud. In the event that you're not using HCP or Terraform Enterprise, this would be the way that you would want to test those. Otherwise, leveraging the HCP cloud, because that's where everything's at, we can leverage the Terraform Cloud Run capability. So that's pretty cool. And that's how we can test many modules in a short amount of time frame using the test framework and a little bit of CI/CD behind the scenes to get that done for us very quickly. Now, mocking, where you just want to pretend for a little while to see what we can come up with. We need to shorten the duration of our tests even more. How can we do that? Why mocking? We have a load balancer Terraform module, let's say. And to test that load balancer module, we need to mock up some IPs. We need to mock up some virtual machines and network systems so that we can feed in multiple public IPs or private IPs so the load balancer can be configured correctly. But we don't want to wait for VMs and NICs and networks to be stood up, so we might mock those to shorten that. So let's see how we can do some of the mocking. Yep, there we go. Back to our storage account. And so instead of building out an entire storage account, if this resource took a long time, things like virtual machines, databases, other network resources, gateways, things like that can take a long time to deploy. So we don't want to actually deploy them. We just want to test the conditions that would come out of them. So we will mock different providers to allow us to get results back from a resource without actually producing the resource. Once we produce a mock provider or a mock resource or a mock data source, we can evaluate and assert the condition against those resources as if it actually existed. And so in this case, I'm going to do an override of a resource and say that the target is the storage account name. And that name should be mocked resource. And I can validate that without creating the actual resource, that it did run the plan in the background and it produced this information back to my run job to assert and validate that information. So essentially, we're pretending to create the resource in the background and ensuring that the output from that resource can still be validated. And so that's a good way of ensuring that we have validated all of our conditions, but we didn't have to produce all of the infrastructure to do so. So mocking and overriding are good things to look at when you need to cut down the time or how many resources are being deployed in order to validate a module. So let's go back into here. There's two different types of Terraform tests. There's plan and apply, and I just quickly review here. They both produce in-memory state files. We need to think about how those state files are broke down with our run jobs and modules so that we're creating resources when we want to and not creating sources when we don't want to. Plans aren't going to catch your API errors. Apply obviously catches our API errors. They can be long running though on the apply side, so using mocking and only testing your high priority scenarios is a critical piece to this. Couple recommendations. The test file naming, they all execute alphabetically. So use numbers to order them so you can test them in a particular order. Use random resources where you can to ensure you're getting unique resources in case there's overlap in the testing. And then knowing how many tests to put in per test file. Combine your plans together. That makes sense. That's easy enough. But your applies probably should be separated so that you can pick and choose and execute them sequentially in parallel versus running them produce them in parallel versus running them sequentially one after the other, which can take a lot of time sometimes. So real quick, what lessons have you learned about Terraform testing? Put that in the chat. We'd love to hear and learn more. A couple shout outs to a few different folks. Mateus has a good comprehensive guide on Terraform testing. There's a YouTube video there called Terraform Test Mocking that it goes into great depth on how to set up mocking. And then lastly, a link to the CI/CD pipelines that I have to show you how you can parallel those tests to test those nightly to ensure you're giving your customers a good product at the end of the day and that something hasn't broke overnight. All right, thank you. There is my LinkedIn, and I will turn it back over to the team to move us along. Thank you, everybody.